Okay, and then we can start to sketch our graph now. Okay, so let's look at this example. We have a hyperbola graph. So just take note, this is type 1 because x comes first. So probably your graph will be a left-right type. Okay, so key features, always find them first. We start off with x-intercept. X-intercept set y equals to 0. Okay, if you set y equals to 0, you try to solve, you get x equals to this. Right? For y-intercept in this case, there's no solution. Let's see why. Because if you sub x equals to 0, can you see that this term here becomes 1 over 4? Okay, if you sub x equals to 0. And if you bring 1 over 4 to the right side, you will get negative y plus 2 square over 9 equals to 3/4, because you minus 1/4, right? And this gives you an error, or rather I should say there's no solution, because this term, because of the square, it is always positive. Together with the negative means it is always negative. Okay, and it means you can never solve for this equation because the right side is positive, right? So this is that. So we can conclude that there's no real solution. There's no y-intercept. Okay. So for turning point, okay, in this case, if you recall the steps just now, to find turning point, we want to maximize the x. So we let this thing to be equal to 0, correct? And then to make this 0, we need y to be minus 2. Okay, if you solve for the x value, you will have minus 1 and 3. Okay, so this is how you find a turning point. Lastly, you find your asymptote. Okay, so for asymptote, okay, let me try to do it. Asymptote, you can use the easy remembering method. Okay, you try to equate this thing to this thing. Okay, and if you try to make y the subject, so if I times 9 over and I do a square root, okay, it will be equals to y plus 2. So this will be equals to y will be equals to minus 2, because you do, when you do a square root, there's a plus minus. If I simplify the 9 over 4, because you square root, becomes 3 over 2, x minus 1, like this. Okay, that's this part over here. Okay, and if you make y the subject, as in you expand the bracket, so you get this 2 asymptote, right? So always, before you sketch the whole graph, plot all these key features first. So I have it here. Okay, the red points are your x-intercept, there's no y-intercept. Okay, the green points are your turning point, and the blue dotted lines are your your asymptotes, right? So you can probably see the shape now, because we know this is a left-right graph, right? So it should be something like that, okay? So my drawing is not good, so let's see the actual one. Okay, it looks like this, okay? So for type 2 will be the same. So I didn't include the example, but it should be fine now. So for ellipse, okay, ellipse, we have the form to be this. If you can recognize the form, it looks pretty much like equation of a circle, x squared plus y squared equals to 1, right? And we link to the earlier lesson that we have. This is like a transformation, right? We transform the circle to an ellipse. Okay, so in a way we can say ellipse is a unit circle being stretched or squeezed and then translated. Okay, so example, we start off with a unit circle, and what we can do is you can substitute x to be x over a, substitute y to be y over b. If you recall, what this does is that it scales your graph in x direction, because you replace x by x over a, right? You divide by a, so you are actually scaling by a factor of a. Okay, same with the y. Okay, you are scaling by a factor of b because you divide by b. Okay, in the y direction. Okay, and then lastly, you can replace the x with x minus h, y with y minus k. We learned that this is a translation. Okay, so it means you translate h units in the positive x direction, k units in the positive y direction. Okay, and you can see this is the equation of the ellipse. All right, so it's just some kind of transformation from the circle. Okay, so in terms of sketching, of course you can still use the idea of using a unit circle, transform and get this graph, but of course we don't want to waste time, right? So the idea, or rather the shortcut, is just that you focus on the highest, lowest point, the leftmost and rightmost point. Okay, and just focus on how they are being transformed. You should be able to sketch the graph of the ellipse. Okay, so let's look at this example. Again, I start off with a unit circle. Okay, the equation is like this. So my equation earlier, okay, I focus on the denominator first. I want to get divide by 2 square. Okay, so essentially what it means is that I need to substitute x to be x over 2. Okay, and y to be y over 3, something like this. Okay, so what this means is that I am scaling my graph, my unit circle, in the x direction by a factor of 2, in the y direction by a factor of 3. Okay, so we just focus on the points. Okay, so you can see that the rightmost point, this one, okay, because you scale by a factor of 2, so from 1, 0, it will become 2, 0. Okay, same for the left point. From minus 1, 0, it will become minus 2, 0. Okay, same for the y, the highest point. Highest point is 0, 1. Now it will become 0, 3. Simply because you scale by a factor of 3 in the y direction. Same for the bottom. Okay, so just take note of these 4 points. You don't need to sketch the blue graph. You just need to take note of the 4 points, right? The next step is to do translation. Okay, again, let me go back to the original equation. I need to replace x by x minus 3, replace y by y plus 1. Okay, so if I do that, okay, if I replace x by x minus 3, y by y plus 1, I am translating my graph 3 units because of this in the x direction and minus 1 unit in the y direction. So basically it will move 3 units to the right and 1 unit down. Okay, so let's focus on the highest point. Let's say this point over here. I am moving 1 unit, 2 units, 3 units to the right, and 1 unit down. Okay, so this point becomes my new highest point. Okay, so all the rest of the points you can do the same. Shift, shift, you get this. This, you get shift, shift. Okay, so on and so forth. Okay, that's it. So once you have the 4 points, of course you can start sketching your ellipse, right? It will just look like an oval shape. You just need to sketch this shape. Okay, so that's the idea of sketching an ellipse now. Of course, there is another way, simply by memorizing. Okay, so we observe that the center of the ellipse, if your equation looks like this, the center is HK. Okay, the highest lowest point is this. Okay, we can try to explain, because the highest lowest point is you want to find the maximum height for y, right? The maximum and minimum value for y. So to do that, I need to make sure that this term becomes 0. Why? Because right now, in a way, the two terms, this term and this term, they are sharing values, because the summation should be equals to 1, right? So if I want to maximize, let me see, if I want to maximize this y value, I want to make x 0. So that happens when I let x equals to h. You can see? Okay, and then if I solve for the y will be k plus b and k minus b. Okay, so same for the left and rightmost point. Leftmost, rightmost means I want to maximize, minimize x. I will want to make this term 0. Okay, to make this term 0, I need y to be equals to k. That's it. So the moment you have the 4 points, you can plot them. Okay, and you can easily sketch the ellipse. Okay, that's the idea. Okay, so for parabola is not in A-level syllabus, but I'll just roughly go through very briefly. So they have this form. Okay, your it's basically like your quadratic equation. You can see y equals to something x squared. Okay, and the opposite is also possible. X equals to something y squared. So this is parabolic graph. Shape wise, okay, let's focus on the green type, this one. Okay, If a is greater than 0, this is what we have seen many times in secondary school. This is your positive coefficient for the quadratic graph. This is the negative coefficient, so it's a set phase. So for the other version, okay, this one, it is basically like a C shape, okay, and an inverted C shape, okay. So you just need to, okay, you don't even need to know, but this is just to introduce to you what are parabola functions, okay. So that's the end of this lesson. Make sure now you know how to sketch the hyperbola and ellipse graph. Parabola, we don't need to know how to sketch, just know what it is. Okay, that's all. See you in the next lesson.